Oh man, I bet you've been waiting to just get to the Kubernetes command line for a while now, but luckily we've got some of the concepts out of the way, so let's get to the command line. The first thing we need to make sure is that whatever you've done with setting up Kubernetes, that it's running. And the way we can do that is similar to the Docker version and the Compose version and stuff like that. We can go to the shell and type in kubectl, that's Kubectl version. And you should get back two versions. This is just like with Docker, where you get the client version and then the server version. Remember that all these command line tools are doing is talking to a remote API. In this case, it's probably the API on your machine. But just like with Docker and Swarm and Compose, the kubectl command line can also talk to a remote Kubernetes API. Now that you've got back the client and server versions, you're good to go. If you got an error, it would probably be because the server version doesn't show up and it says it can't connect. That means that somehow you're misconfigured and your local CLI can't talk to the Kubernetes server. So I would either check how you deployed it to make sure that it's running. Maybe if you're on Docker desktop, you need to start Docker and then also make sure in the settings that Kubernetes is running. And if it's some other way, just check the install video. If you have any issues with that, reach out in the Q&A or in Slack. All right, there's two ways to deploy pods in Kubernetes, really. There's doing it at the command line where you're specifying all the options at the command line, or there's using YAML. So this might be similar in concept to services and stacks in Swarm, but of course, when you really get down to it, there's a lot of different stuff under the covers. So I hate to make that analogy, but that's really the two options you have, is either command line or YAML. Let's focus on the command line for a few minutes. And the first command we're going to run here is kubectl run, so it's similar to a Docker run, my nginx, and you can call it whatever you want. This is the name of your deployment, and then -- image, and we'll specify the image name here. Let's just use nginx like we're used to, and hit return. Now for a minute, let's ignore the depreciated warning if you're getting that in some of the recent versions of Kubernetes. We'll talk about that in a little bit. But for now, let's see what just happened. And we can use that with the kubectl get command. Kubectl get pods. And what you should see there is your named object along with some characters on the end of it, and you'll see that 1 and 1 is running. So this is very similar to the services concept in Swarm, where we, by default, just ran one replica, and you can see that's named there. But why do we have that weird name? Well, this has to do with the way that the kubectl run command works. When you're using the run, as it is right now in version 1.14, that is technically using a deployment controller. And that deployment controller creates a replica set controller, and that replica set controller then creates the pods. In this case, it's just one replica, so it's only one pod. If we did a kubectl get all, you would then see all the objects there listed, and you'll see pods. Ignore the service for now. We'll talk about that in a little bit. The deployment, and then the replica set. So you can see these different layers of the object model in Kubernetes coming out here, where we just did a single command, but it actually created multiple objects for us. Let's go to my drawing board and describe how these objects relate to each other. As you've seen in Kubernetes, we have more levels of abstraction and control than we did previously in Swarm or in Docker itself. In this case, when we did the kubectl run, it in the background created multiple different abstractions automatically for us. It created the pod, but it also created around that a replica set and around that a deployment. So let's go to the drawing board and I'll show you how these abstractions relate to each other. So as a reminder, we have Docker running underneath, and then we have some containers running that are managing Kubernetes, and I won't talk about those rights now. So let's just know that we have this different set of containers over here just to run kube. And when we did the kubectl run, what it created was obviously our nginx container. That was the part that we know about. But the different levels of control or abstractions are the interesting part. The first one here is the pod.
And again, it can run one or more containers inside this pod. And as a part of that pod, it could have created volumes if we needed it, and it created the NIC for the pod. Now, the way it created that pod was when we typed kubectl run, it created a deployment. And a deployment controller manages replica sets. So we have multiple levels of abstraction. That deployment was created, and it does things like rolling updates or blue-green deploys, and a lot of other things that you think about when you think about orchestration services like we had in Swarm services. When that deployment was created, it created a replica set of 1. And that itself is another controller. And the replica set's job is to make sure that the number of pods we asked for are currently running. In this case, we left everything at the default, so our deployment created 1 replica set, and that replica set created 1 pod. Now, we could control each one of these different levels of abstraction. We could type commands to control the deployment, the replica set, or the pod itself directly. But usually in these situations, you're always going to be managing the deployment itself, and then it will take care of the rest. And to give you an idea of why the replica set itself in the middle exists, is if we wanted to create another copy of this pod, just like when we do Swarm service replicas. So in my drawing here, I created a copy of that pod, and that would be if we scaled the replicas to 2, very similar to how Swarm does it. And the replica set's job, again, is to ensure that 2 pods are running with the identical template. And the deployment's job is to manage the replica set configuration.
Before we jump to the next lecture, let's delete all of these resources we just created with the run command by using the delete command. Now, this is different than Docker, where Docker had the remove command. Now we're using a delete command with kubectl. And you'll notice that we're specifying the type of object and then the name of itself. So we're doing deployment space, the name of the deployment. And when you do that, it will delete all the things underneath it, the replica set, the pods themselves, and the containers in them. We can verify that quickly with the same get all command. And you'll only see the cluster IP there, which is the Kubernetes server itself. Real quick, before we get to the command line stuff, because that's important, that's usually how you interact with Kubernetes, is through the command line. And there are lots of options with Kubernetes. That's one of the main themes you'll see throughout this conversation I'm going to have with you about Kubernetes, is that there's lots of ways to do the same thing. And that's because Kubernetes, unlike some of the Docker tools, comes very unopinionated. It allows you to do things in various ways to fit your workflow and basically your team's preference. The challenge with that is often knowing what to do. What's the right way for you to do something? So that requires a little more investment in learning the tools. So in this quick lecture, I just want to warn you or educate you on that there are multiple ways to do this. And so sometimes when I show you a command, there are multiple other ways to do it. And the specifics that you'll see, whether you're looking on the blogs or in the Kubernetes documentation, are on the 3 main commands. The 3 I'm talking about are kubectl run, kubectl create, and kubectl apply. You'll see a couple of examples of using kubectl run. It's probably the closest to Docker run that you would experience. And then kubectl create can be a similar experience to Docker create for Swarm, right? And then kubectl apply might seem similar to a stack deploy with Swarm. And that's the best way, if you know Swarm, to figure out where these belong. The apply command at the bottom there, that is mostly for YAML. That's really the only thing you're going to be doing there is applying YAML differences to your environment, and you'll do the same commands for creating or updating things. The kubectl run, we're going to start out of the gate with, and you'll notice that there's going to be a warning in the next lecture, or if there isn't, then I've maybe replaced that lecture. But there are warnings because kubectl run is changing, and it's actually reducing its scope. It used to be something we would use to create all sorts of different things, and there was automation in the back end. But nowadays, the plan is they're going to reduce and deprecate a lot of the features that Run has so that it eventually only is designed to run a pod. So you'll learn all about that later, but just know that throughout the next few videos and sections that you'll see kubectl run and sometimes kubectl create commands, and you might even see future commands like expose and apply, and just realize that there's probably other ways to do these commands. I don't always have a preference for which one's the right one, but you'll learn as we go that depending on your style of working, whether it's imperative or declarative, we'll get into that later, that will indicate whether or not you need to use a certain command over another. So just be aware that those are there, and let's get started. Now, similar to Docker Swarm, in it using replicas as the term for the different containers running and deciding how to scale up and scale down using the number of replicas and also the scale command, we had that similar experience with Kubernetes. And let's check out the kubectl command line and how that's going to work. First, we're going to need to start a new deployment. So let's go back and do a kubectl run my Apache -- image HTTPD. So unlike Nginx, we're going to run an Apache web server this time, mostly just because it does give us some default logging out of the box so we can at least look at logs. Now we can check that all those objects have been deployed with another get all. And once your desired and current are ready to go on your replica set as well as the pod, then we know we're ready to do the next command. So this default run gives us a single pod or replica. Let's scale that up to 2. Notice that I typed -- replicas 2 here with the scale command. And I also put in the type of object, in other words, a deployment, and then the name of that deployment. But there's a different format you noticed I've used here. I've used a deploy rather than deployment, and I've used a / rather than a space. This goes into a little discussion around the flexibility of the Kubernetes command line. You'll notice that a lot of commands have short versions of the command itself, and different parts of the command can be abbreviated or substituted in various ways, like a / versus a space, stuff like that. So in this case, the scale deploy / my Apache would be the same as scale space deployment space my - Apache. Those would be the same equivalent. And you can basically, in a lot of places where you would see the deployment option, you might be able to specify deploy, deployment, or deployments in the plural state. And you'll notice that this is sometimes similar in other parts of the command line where plural or singular work just as well, or sometimes you can abbreviate part of the command. Honestly, over the years, this has changed. So it's not so obvious which parts you can abbreviate or put in a / for a space. But I think once you get used to your own way of doing things, that'll just work for you. Now, if we do a quick kubectl get all again, you'll notice that we have 2 pods now, and you'll see that the replica set at the bottom has a desired state of 2, and 2 are running. So in the general concept here, this is exactly what Swarm services do. They scale up and down replicas based on your requirements. And in this case, we're just talking about pods rather than tasks. So when we did the scale command, let me give you the basics of what went on in the background. Because we have extra levels of abstraction, we need to understand how these levels react to each other. So when we typed the scale command, we were technically updating the deployment spec. In Kubernetes, everything has a spec. And this spec for the deployment changed the replica set to a set of 2 replicas. Then that replica set controller decided to change it to 2 pods, and there would be 1 pod for each replica. And then the control plane makes a decision about which nodes, in this case you've only got 1 node, but which nodes would get assigned those pods. And then if you had a multi-node setup, the kubelet agent would then get assigned that pod and would take that for execution to create the container on its local Docker engine. And while it seems like this is a lot of work going on in the background simply to start another container, it actually happens really fast. In fact, it happens almost as fast as Swarm. Generally, we're talking about a second, 2 seconds, something like that, when you're talking about a single machine. With Swarm, one of the advantages it has is that everything is in the single binary, so it happens a lot quicker because it's really just happening inside the same process, including the launching of the container itself. With Kubernetes, we get these additional layers of abstraction, and that does introduce a slight delay compared to maybe something you would do on Docker or Swarm, but really, in most cases, it's negligible. And the trade-off is we get much more flexibility and control with these different layers of abstraction. Oh, and don't clean up on this one. We're going to use these Apache containers in the next lecture when we do some inspecting of what's going on in Kubernetes. If you didn't come directly from the last lecture on this one, go back to the previous lecture to make sure that you have the proper deployment running so that you will have the logs that we're going to see here in a second. And since we have that Apache deployment running in the background and it has 2 pods, because we scaled the replicas to 2, we should be able to do a kubectl get pods and see the results. Now, of course, your pod names will be slightly different than mine because they'll have the numbers and random characters on the end there. So whenever I am typing it, just realize the last 2 blocks, you will be typing something different based on what your deployment is showing. Now, there's a few commands, just like with Swarm and with Docker itself, but in this case, they're different commands for understanding what's going on in the container and what the orchestrator is doing with containers. And the first one is logs, and the second one is describe. We don't technically have an inspect command in Kubernetes, but describe does much more than that. So first, let's try a logs command. Now, your output might be slightly different than mine, but you'll notice that the first line after we typed in the logs deployment / my Apache, it says found 2 pods and using a pod name. It gave a specific pod name there. That is because the default log command won't pull all the different pods and combine them together like you would with the Docker or Swarm commands. It's only by default going to pull one of those. And like other log commands you've been used to in this course, there are lots of options, including -- follow, -- tail. Those are common things for logging commands in any Linux system. So if we did that same command with -- follow, it will then wait for anything new to show up in the logs of that pod, and then -- tail 1 just means return the last line only, and that way you don't get a huge dump of the logs. And you can Control C out of that. Now, what if you wanted to see the logs combined for multiple pods? You can certainly do that. That's just not the default logs command. In this case, we're going to have to use something called a selector in Kubernetes, which is a technique to grab multiple pods based on a label that they all share. Now, the nice thing here is when you use the kubectl run command, it automatically added a label of the name of the deployment to all these pods. So we can use that same deployment name, my Apache, for selecting all the pods with that label. Note that this is just a simple matching of a label here. So if you had other deployments or pods that happen to have this label, they would also be caught up in this too. So you have to be careful with your labeling and your naming. So we're using a -L here to specify the label, and we're specifying the label that the run command applied, which was my Apache. And just like Swarm and Docker itself, these log commands can be very handy for quick troubleshooting, but are not the replacement for a full log system. In Kubernetes, by default, it can only pull up to 5 pods at a time when it uses this selector type of pulling on the logs. And you can always increase that, but the reality is it's taxing on the system to pull from all the different nodes these log files. So in production, you're going to want a third-party logging system that would collect all these logs and store them over time for quicker retrieval. That's true of really any container orchestration system, whether it's Docker, Swarm, or Kubernetes. Now the next command here would be the describe command. But the describe command in this case is where we want to specify the pod itself. We want to get a very specific pod, but then we need to know the names of those pods first. So let's get pods first. And then we can copy and paste one of those names into a describe command. We have to type pod first. And I'll get back that pod. Now, I don't necessarily have to specify that one pod. I could say pods and it would show all pods, which could be a little dangerous if you have lots of pods. And you can certainly describe other resources and get back various types of results based on the object. But what I wanted to highlight here was that this would be similar to the inspect command in Swarm or in Docker itself, but it gives it a little bit nicer display on the screen rather than in JSON. And as you scroll down the results, you'll notice that it's not just a description about the different object, but also pulls up things like events at the bottom, which is a great way to get quick status on the current reality of that object. So in case you're having a problem maybe with a pod pulling an image, you would see that event here where it would say unable to pull image. That's a common one for when you're accidentally mistyping an image name or something like that. So this can be pretty handy for a quick troubleshooting technique without having to go turn on some events or debugging logs. All right, for this last little bit, I'm going to show you how Kubernetes is resilient, similar to Swarm, where if you delete one of the lower levels of abstraction, in this case, if you delete a pod, the higher level abstraction, the deployment, and the replica set will make sure that that pod is recreated. That's similar to the way a container or task in Swarm, if you delete it, would be recreated by the service. So we're going to do this in two different windows. In the first window, we're going to use a git with a -w. So that is going to give us a similar experience to the watch command. If you've ever seen me use the watch command in this course, to watch any Linux command, which essentially means to run that thing in the background. And you could do that in Linux, but that watch command is not always available on all OSs. And here we can do a kubectl git pods, but add a -w, which will let it sit there and refresh every few seconds. And now we can go to a different terminal and we're going to delete one of those pods. So first we'll need to copy the name and use a kubectl pod / the name of the pod. And you'll notice that it's deleting it. And we'll then get this running log up top of the things that are changing. I also like this a little bit better than the watch command because the watch command refreshes the screen where this shows an ongoing iteration of the changes, which is pretty neat. And down at the bottom, if we did another kubectl git pods, you'll see that we're back to 2. So again, this is sort of the self-healing aspect of an orchestrator. That's one of the main goals of having one. And lastly, I want to point out something here where you might have been protected in the past from doing certain damaging things in Docker or Swarm, where if you tried to change something or delete something that you shouldn't, it might warn you ahead of time. Kubernetes tends to fall on the other side, where it's a little less opinionated about how you use it, which means that you can sometimes do things that you shouldn't, such as my example earlier of modifying a replica set instead of modifying the deployment above it. The same could be true of changing a pod when you really shouldn't be doing that. You should change the object above it. And that just stresses that you need to understand the specifics of what you're doing so that you don't accidentally delete, change, or modify the wrong thing in the wrong order. And remember to do a kubectl delete deployment my Apache to clean up from this lecture.